We are Risky Business, tackling Challenge 5 of Project Hack 19. This is our team, a selection of students, project management staff and control staff. To do this, we developed a risk identification form. And the idea being is that we moved the risk description as mostly free text to allow it to prompt the building of the risk description through selected categories, which allows us later on to assign this to both PESTEL and to then analyze the risk entries by those various topics. We've applied that same thinking to both the cause and the consequence of the risk, so that we can provide a much deeper analysis on a risk automatically without interpreting what could be worded differently by different risk managers. The PESTEL analysis will be done via a chart demonstrating a ratio rather than a count, which can be done either ratioed on number of risks or the impact of them, to give an indication of where those biases are. What we'd see going forward using historical data and collected data in future would show a profile for what would be a typical project of a particular type. As an example, an IT project would have a higher level of technical risks and a lower level of environmental risks, at least that was what we would expect. This allows us to predict whether there is a number of risks which may not be relevant that have been included, or whether we may be missing something in our analysis of those risks. All of this output of collection is input into Power BI and provides an output of various reports, allowing to look at both project level and organizational level, as well as look at a history of risks raised and breaking them down by departments. In the bottom right of the screen, you'll see a breakdown of the risk description dropdowns, which allow us to look at a particular area's risk. In this example, we'll be looking at finance, and then what of those finance risks are linked to budget, and what the definition for those risks is around insufficient budget. We can then also look at the cause, which is also filtered in via that collected data. This allows us to take away some of the ambiguity of a risk description. Using that data and analysing it, we can assign these to various areas of PESTEL, and this gives us an indication of where those risks sit, where we've got highest impact, and where the severity of those risks sit in our given project.
So these are our ideas for future development. So the first one I want to discuss is Similarity Index, then how we can use scatter charts to do a sanity check, and also checklists. So Similarity Index, so we've got this idea from students who submit dissertations that goes through a system called Turnitin that generates a Similarity Index. It's quite easy to generate a Similarity Index. There's various algorithms we can use to do this, one of them being the cosine similarity. So the idea is, as the user enters the risk, it then produces a Similarity Index and gives them a list of all the risks which are similar to the one they've just entered, which are already on the system or in the data set. They can then choose to ignore that and carry on with a new risk, or reuse one of the existing ones, and it will auto-complete all the required fields. These data sets could be shared between organizations, giving us a broader data set in which to base the risks on. We can also use scatter charts to do a sanity check. So we could trend or plot cost and duration against risk and uncertainty, or number of risks and level of contingency, various combinations of those, which then allows us to draw a trend line. The trend line can then be used to give us some estimation in terms of how long something should take or how much contingency is required. So a quick example, if it was a crane installation, based on a number of data points from previous crane installations, we can see here that the crane installation is typically value £420,000, then typically it should have 22 risks. So it's a made-up example, so but it gives you some idea of how we can then use this to do a sanity check on comparing it to our project and say, for this type of project, do we have enough contingency? Do we have enough risks? In terms of checklists, these can be based on historical projects, which was been based, generated over a period of time, and some of the common risks for those types of projects, and then pulled out and added to the list. So you've got things like hazards, budgets, cause of delays, environmental, weather, etc. And we can use these as prompts to make sure that we're generating what we would be typical risks on those types of projects, and then the database would be grown over the period of time.
So how do we see this working in practice? In the short term, we'd be able to begin data collection immediately using the risk identification form, but with the understanding that our stuff that's already in existence would need to be reanalyzed using the new drop-downs as we move forward. Moving forward with that in the midterm, we could look at implementing the PESTEL analysis and getting that presented in dashboards, and we can start analysing that data through the new management system. We can aggregate that collected data back into a data bank, which we can then use to inform additional drop-downs that might be required, any gaps that we're missing, and then feedback in an iterative loop as to where risks may be missed from some of our profiles. And on the longer term, I would like to see introduce that Similarity Index, the scatter analysis and the sanity check and the checklists, and ultimately longer term with the data as it builds up over time, we'll be able to get more and more accurate profiles to inform projects both at the beginning all the way through to completion of a project. So our key benefits from this, a standardised risk management system for any organisation to use because we're keeping the terms broad while still specific enough to get valuable data from. We'll be able to incorporate other data sets and risk catalogues and be subject to be changed and upgraded by organisations in the future and as this data set increases in size. Efficiency-wise, this is both user-friendly both for data collector and data analyst to boost both efficiency and effectiveness. And we can compare between internal projects and provide data-driven risk mitigation, whilst also providing a data set that can be compared and benchmarked against other organisations. We're also doing from an efficiency standpoint is allowing us to compare two risks that are similar, so we're not duplicating effort, whether that be risks that are already in existence and open or risks that have been closed where we can pull useful data from. So judges' questions. So question 1, how have we minimised the number of redundant risks in the register? For what we'd do from the similarity checking, the Similarity Index is be able to identify where those risks already exist, but also just from the initial impact of adding those drop-downs to the risk description, allows us to clearly define how to filter down these risks that may be similar, but worded differently as we're taking some of that ambiguity out of the risk description. So how does a decision maker use the outputs from this tool? Well, it really depends on what angle they're looking at from. From a profile specs, they can have a look to see how each of their projects lines up where on the PESTEL scale they'd expect those risks to sit, if there's any particular bias towards a certain area. But we're also able to filter down via large departments such as finance and understand whether there's a pressing issue around the likes of budget from the dashboards that are outputted. Collective risk in a standardised way, so introduction of the entry form with these drop-downs ensures that the risk descriptions, all these free text fields that are currently in use in most risk management processes are reduced down to something that's more standardised and also removes any of the human error such as mistypes or misspellings. But also the use of something like a Microsoft form, for example, that we've used to this, or something bespoke developed for it, which means we're able to apply that standard approach to collection in various formats, whether that's collected on a handheld device at the moment that the risk is identified, or on a tablet at a construction site, or actually sat in a risk workshop at a laptop or computer.